In a large city, a significant positive correlation was found between car accident increase and umbrella sales. Correlation is a mutual relationship between two or more continuous variables. We will analyze these and other examples to calculate correlation and analyze regression using Microsoft Excel. Download this Excel file from OneDrive to your PC to run the following examples. We have collected natural gas demand data in sheet correlation. This is actual daily demand during the month of January and the average local temperature recorded on those days. From the date timestamp, we have computed the day of the week, one being Monday. We are looking for factors that may affect demand, and two possible factors may be temperature and day of the week. We have used Excel data analysis correlation between these four columns and obtained these results. We detect a negative minus 0.85 significant correlation between demand and temperature. The lower the temperature, the higher the natural gas demand. This is what we would expect. We see no significant correlation, minus 0.21, between day of the week and demand. No significant differences on weekends, for instance. On the other hand, we see a significant negative correlation, minus 0.76, between demand and date, which we did not expect. As dates increase, demand decreases. The explanation is that there is a positive correlation between date and temperature. Temperature increased as January advanced. A date increase caused a temperature increase, and this caused a demand decrease. Now that we see a strong correlation between temperature and demand, we will apply linear regression to approximate a straight line to that relationship. We want demand y as a function of temperature x. R square of 0.73 indicates that 73% of the variation of the demand is explained by the variation in temperature. The p-values of the coefficients are below 0.05, therefore the straight line is a good approximation. The equation of the demand prediction as a function of temperature is therefore demand equal to 15.11 minus 0.55 times temperature. You can obtain the regression line with Excel scatter chart directly from the X and Y data. Select linear regression. As an option, you can also display the formula and the R-square value. Looking at the graph, we notice that the actual values differ from the predicted values represented by the straight line. The differences between the actual and predicted values are the residuals provided. In order to validate this mathematical model, we need to check that the residuals meet certain conditions. The first one is that they are stable a long time. We will check that with an individual's SPC chart. In this SPC chart, we see no out-of-control symptoms, so it meets these conditions. The second condition is that the average of the residuals is close to zero, and they follow a normal distribution. We notice the average is zero, and the p-value of the Anderson-Darling normality test is 0.42, well above 0.05, so it is normal. This validates our mathematical model. In sheet multiple regression, we have collected output variable y and input variables a, b, and c. We are looking for the relationship y as a function of a, b, and c. We start with a correlation analysis among the four variables. We see no significant correlation among the input variables, but significant correlation between inputs and output y. We will now do a regression analysis. We select Y range as column D and the X range as columns A, B, and C, always including the headers. R square of 0.98 confirms this model accounts for 98% of variation. Coefficient P values below 0.05 also confirms the validity of the model. The formula enables the estimation of output Y as a function of variables A, B, and C. In this case, we have no graph possible. We will need 4 dimensions. In seed regression interaction, we have data of output Z and input variables X and Y. We will try a linear regression to estimate Z as a function of X and Y. We observe a poor value for R square, 0.36, and we suspect that maybe there is an interaction between inputs X and Y affecting the output Z. To check that, we add a column to our data to compute X times Y. We will use this new column as an additional input variable. Now we are looking for a regression equation to estimate Z as a function of X, Y, and X times Y. Now we see a much better I square, 0.99, and therefore a much better estimate for Z. Coefficient P values are also below 0.05. This is the resulting formula for the estimate of Z. With this graphical representation, we can see the highest Z values in green and the lowest in red. The maximum Z is for the maximum Y and minimum X. The lowest Z is for minimum Y and minimum X. We want to calculate the relationship Y as a function of X in seed quadratic. We start checking for correlation. We notice it is very poor. Now we will plot Y as a function of X using a scatter chart. In the Excel scatter chart, we clearly notice Y equal to function of X is far from linear. A quadratic formula such as Y equal to A times X squared plus BX plus Z should give a good approximation. So we will add an X squared column to our data and do the regression with this additional column. Now our R square of 0.99 and coefficient P values confirm that this model with the quadratic term gives a much better approximation. You can directly obtain the quadratic trend line and formula and R square value with Excel directly from the X and Y data using a scatter chart. We select a polynomial order 2 trend line and select display equation on chart and R square value. There is a significant positive correlation in the city between umbrella sales and traffic accidents. What is the cause and what is the effect? It is obvious that none is the cause of the other. Then, how can you explain this correlation? The rain is the common cause of the increase in umbrella sales and car accidents. So we conclude that significant correlation between two factors does not necessarily mean that one is the cause of the other. There may be a common cause of both. Humidity and arthritis are positively correlated, as older people will confirm. Is humidity causing arthritis? The answer is no. It is the drop in atmospheric pressure that causes both rain and arthritis. A good correlation is a necessary condition for causation between two factors, but it is not sufficient. Let us now look at some conclusions. When there is a significant relation between two variables, this can normally be approximated with a formula. To be able to estimate one as a function of the other, the cause-effect relationship needs to be established clearly. In case of doubt, design of experiments, DOE, may help. If we have a good correlation, a linear regression can be a good approximation, that is, a straight line. Residual analysis provides additional confirmation of the mathematical model. An output variable in the process may be correlated to several input variables. We can calculate a regression equation in Excel also in this case. A nonlinear relationship can normally be characterized by a higher level polynomial equation rather than a straight line. Other Excel data analysis tools may also be useful. You can read this article in Polyedrica Blogspot. These are other related articles in Polyedrica Blogspot.